All right, so the time now is 11:40 p.m. I want to do a very quick video just to go over one problem that I did. April 9th of 2026, and I skipped the past few days because I was quite busy. So today we'll look at word search. So actually this problem I actually solved it beforehand, and because I wanted to do a quick video, and sometimes it can get quite hard to talk and code at the same time, especially if you watch my 1 hour plus long videos. So, word search is a medium question, and it falls under the backtracking problem. And backtracking is very closely related to depth first search. And of course, in this case, it's a matrix. Yeah. So, given a 2D grid of characters, board, and a word string word, return true if the word is present, otherwise return false. For the word to be present, it must be possible to form it with a path horizontally or vertically. Yeah, so this is something like a blood field or island question. So the same cell may not be used more than once. So this gives sense about how there should be some hashing involved. So of course, if you don't want the same character to be used, because if let's say the word is CAC, in this case, CAC doesn't apply, but if you go down, you might go back up. So the way to do this is really quite simple. The time complexity given is crazy. You have OM, where M is a number of cells, which means that in this case, you are allowed to do a double for loop because that's a number of cells you have to go through. And on each cell, you will perform depth first search, similar to how flood field is done. So you look at this 4 to the power of n, it shows that there are always 4 possible paths for each cell that we look at. And in this case, because it's 4 to the power of n, we will have to assume that every cell that we visit, m times 4 possible paths on each side, which is why the input size is very small. Yeah, so it's maximum of 5 by 5 matrix, and the length of the word is maximum 10. Okay, so there's not really a lot of edge cases, and the solution is actually quite straightforward because you brute force it. So first of all, because of this unique, you can only use each cell once, not each letter, but each cell once. I will use a map to store the visited. Okay, so there are two main tricks to this question. The first is, of course, quite basic. Always check the domain first. So you always got to check that if your row or column is out of the parameters given, right? Always return false because you cannot possibly get a word with that's beyond you can't even access the matrix. So always return false. Return early so they don't access data that is not supposed to be accessed. Okay. Then if the character is not the one that you're looking for example, if let's say just for simplicity's sake, we're looking at cat, A is definitely not the first letter of cat. We don't start the search at all. So we just return false. Or we have visited, let's say I'm at C and now I'm at A, right? I'll look at C again. I've already visited C, so I will return false straight away. Okay, so the first trick is to always check the domain. The second trick is not so, it's a bit language nuanced. So for JS, there is no explicit tuples. So I had to serialize the key for the map because there are two values. We can't just use for JS, cannot use visited dot set row column. Yeah, because in this case, you will only look at column. So just a quick reminder if anyone's using JS out there, the trick is actually just to look at to serialize it to be row column with a comma in between in a string format. Okay, next. At this point, if I is equivalent to word dot length minus 1, which means I've verified that it is part of the string and the current character I'm at is the last character. It means that I found the whole entire word. I can return true at this point. Okay? So now that we've got all the cases done, we will look at the backtracking part of it. So of course this character is valid, right? I will have to set visited at this serialized row and column to be true. Okay? And because I'm just setting it to be true, as long as it exists inside the map, I can always use has to verify. I don't have to get the value, I just need to check if has. Okay? Next, the result will be an OR between 4 directions, meaning the row below it, the row above it, the column in front of it, the column behind it, and we'll be looking at I plus 1. So why does DFS have I plus, have an I parameter? Because I is actually the index of the character we're looking at within the word. So which is why if I is equals to word dot length minus 1, we know that we are at the last index of the last letter and it's a match, and we can just return true. And why is it a logical OR instead of an AND? Is we just need one possible combination of this word, regardless of what direction it takes. Because we can take an L shape, we can take a snake shape. As long as it's a valid combination, we will return true. So we just need one of the DFSs to return true amongst all of the DFS. And of course, because we want to have to prevent the same cell from being visited or used more than once, we will set it first, perform the operations, backtrack. So the backtracking occurs here when you realize that, oh, I can't do anything about it. I will return false and then I'll backtrack. I'll delete the key that I visited. So the backtrack happens here. And of course, at the end of it all, I will keep recursively returning the rest until my DFS returns here. So I run this DFS on each index, each coordinate, the row and column, with index 0 as a starting point for the word. And of course, the answer. If answer is true, I'll return true. If not, I will continue. And once the loop ends, I'll return false. And if we run this code, it works. So just the mini overview. I'm currently 50 questions in of blind 75. I don't know how long more I plan to continue this. My initial goal was actually to complete blind 75 at the minimum, but currently I'm exploring some system design questions. Not questions, but some system design topics that I'm interested in. So we'll see how it goes. The current streak has been crazily repaired and padded with past submissions. So 31 is kind of fake. I did not code straight for the past 31, but I have visited this website and submitted something for the past 31 days. And yeah, so currently what we have here is that we've completed quite a few topics. And of course, trees is a big one, dynamic programming is another big one. We'll keep looking at it, and I'll see whether I find the time to complete this. Okay,